Welcome to the video presentation for the final project Criterion 7 for CompTools. This is Jordan Albino, and this project is about implementing a GUI system for step response, bold plot, and root locus, and transfer function. So you see here, these are all the properties that will be implemented into the app, the GUI app, as we'll see soon. Scroll down. It allows us to reset. We created a reset button so that whenever you need to reset like your input values, you'll be able to put another set of values whenever you want. And it will clear out all the plots, all the tables, and anything that was added from the previous inputs when you press the reset button. And these are all the functions that will be called out, like the frequency, the numerator, the denominator, and it allows you to retrieve those inputs and parse them. And you have to create, of course, create the transfer function so that all this can work. And you also need to generate the the frequency, the magnitude, and the phase as well. And then it also shows the plots for each of the stuff that's included into the GUI app, as we'll see soon. It'll show the plot magnitude, the bold phase. It'll show the step response and the root locus. Scrolling down, it'll show you like all the data from the tables. Um, Even right here, it'll show you the table as well. And then here, we need to check the stability of the system, whether the system that you inputted from the transfer function will be stable or not. So this is the code that's needed to show the stability of the system by implementing the poles and the zeros of the transfer function. And over here, it shows the if-else statements for whether it's going to be stable or not. And it'll show a prompt on the GUI itself, as we'll see later on. See, it says here, it shows some conditions, like if it'll show if the system is asymptotically stable or Beeble stable. It'll show that it's marginally stable and Beeble stable. And it'll show some other stuff, like if it's unstable. And that allows us to call back these functions from the table as well in the reset system as well. And when the button is pushed, everything is literally reset. All the graphs, even the inputs that you put down, all the other special data will all be wiped out and cleared. And it'll use these functions to do such things, to wipe away any unnecessary stuff that when you press the reset button, it'll wipe away all this stuff over here and delete it as well. So if you continue to scroll down, it shows like some of the stuff for the root locus, the real part, the imaginary part. If you continue to scroll down, you see more function displaying and section changes. And here's some like component initialization. They'll show the bold plot, the step response plot. It'll show the UI figure and everything. Basically, all this stuff is to be included into the GUI app. Even creates the buttons as well so that you can analyze once you put your input, you are able to analyze as we'll see, and reset as we also will see. So all this is just to create the necessary components for this said GUI project that will shown very soon. And that's pretty much it for like the rest of this code over here. Now we run it. Unfortunately, it does look a little finicky, so I had to fix it up a little bit. If I do this, I fix it up a little bit. I can't full screen it because it'll mess up again, but as you can see right here, there's the numerator, the denominator, the frequency. These you get to input it. I'm going to put the exact numbers that are shown here. Make sure to include the square brackets as well. I can put whatever number I can here, but I choose to use this as a way to show it. As of right now, these are all empty. As you see, when I press the analyze button, give it some time, and it'll show all the necessary stuff like this, the step response over here. Unfortunately, it does get cut off a little bit, but it does show a bit of the step response and the overshoot and everything. It even shows you like the time as well when you mouse on it. You know, it shows the root locus, the bode plot magnitude, the phase bode plot. It shows some gain margins and phase margins around here. It shows the parameters that are needed for the step response. For example, the rise time, the settling time, the transient time, and the percent overshoot. Is all that shown here. Is shown here. If you go down here, it shows the stability of the system, and it says right here, for example, that this system is asymptotically stable and Bebo stable. It shows you the zeros and it shows you the poles right here. If I press reset, everything is gone, and I get to put another set of systems. Let's say this is 1, or let's say this is 2, this is 5. Let's say this is 1, 6, and 9. All right, and let's change up the frequency a bit. Let's make this 2, and let's make this 200. And let's see what happens when we analyze. It shows a much different system now. As we can see, it shows the bode plot, but cut off a little bit because we're starting at 2 instead of 0.1. So that's why certain parts are cut off. But maybe we could reset it to fix that up. Oops, have to do it again. 2, 5, 1, 6, 9. Let's put 1 this time and 200, so it could show more. It's probably not gonna work because let's see if it works now. Yeah, it shows more now, and this is the root locus right here. It shows this guy right here. And you can hover over to see what's going on at any point. It still shows the table. It still shows some data here that's different. It shows the plot, a different plot and a different phase. This time, it still shows that that the system is asymptotically stable and Bebo stable, and it shows the zeros and the poles as well. So yeah, that's about it. Thanks for watching.